Problem 7. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals square root x, y equals 0, and x equals 4 about the x-axis. All right, first of all, I'm going to start off by drawing a picture again. We've got y equals the square root of x, y equals 0, and x equals 4. So it's going to be this shape right here. We're going about the x-axis. So if I'm going about, whoops, wrong one, about the x-axis, it's going to kind of come on over here. And I notice that this whole thing is touching, and since it's over a horizontal axis, we actually get to use the disk method for this one. So my volume will equal pi, and then I'm going from an x value to an x value, so I'm going to go from 0 to 4. And then I'm going to go ahead, since it's disk, it's only one radius, so the radius is going to be the square root of x, and it's the radius squared. Okay, and then from here, just figuring this out, we're going to go 0 to 4. The square root of x when you square it is just going to be x. And then if I take the integral of x, that will be 1/2 x squared. And I'm just going to let my pi tag along. I'm going to plug in 4, and then I'm going to plug in 0. If I plug in 4, I will get 8 as an answer. If I plug in 0, I will get 0 as an answer. And still my pi is hanging on for the ride. I will end up 8 minus 0 is just 8, and then I have 8 pi. So that would be the volume of that figure. Question 8. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x cubed, x equals 2, and y equals 1, again about the x-axis. So let's go ahead and get a picture of what that looks like. So y equals x cubed. We've got x equals 2. And then, well, that one we've got y equals 1. So kind of hard to see here. I kind of did a sideways graph. It's actually just going to be this little part right here. So, and we're going about the x-axis, so you'll notice if I try to retrace that, it would kind of come over here. Since it's a horizontal axis, it's either disk or washer, and since there's definitely a hole, we will use the washer method. All right, so when we're using the washer method, it's volume equals pi. It's going to go from an x value to an x value. So I need to figure out where the line y equals 1 and the line y equals x cubed intersect. So I'm going to go ahead and do a point of intersection. I want to set x cubed equal to 1. If I cube root both sides, I'll get x equals 1. So they are intersecting starting at 1, and then it goes over to the line x equals 2. And then for washer, we want to do the outer radius squared minus the inner radius squared. So if I'm looking at this, and again, I'm going to try to make it so if I draw a line through it and I put little dots there, which dot is furthest away from the x-axis? It's going to be this dot right here, and that's the curve x cubed. So I'm going to have x cubed squared minus the inner one would be the dot that's closest to the x-axis, and that would be y equals 1. So it's going to be 1 squared dx. And so when I do this, I will get pi, it's going from 1 to 2, x cubed squared, you're going to multiply those exponents. So you're going to get x to the 6 minus 1. And then from here, since there's a minus sign, you can go ahead and take the integral of each part separately. So I'm going to get 1/7 x to the 7th minus x. I get to evaluate it at 2 and 1. Don't forget that we've got a pi hanging on there. When I do that, if I plug 2 in, 2 to the 7th power, you could just think 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, one more times 2 is 128. So this is going to be 128 sevenths minus 2. And then minus, if I plug 1 in, I'll get 1/7 minus 1. I'm now going to get common denominators for all my parts. I'll get 128 sevenths minus 14 sevenths minus 1/7 minus 7 sevenths. So this one will give me 114 sevenths minus 1/7 minus 7 sevenths is going to be negative 6 sevenths. Those will turn to plus. So I will get 120 sevenths, and then don't forget we have our pi. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals 1/2 x minus 2 squared and y equals 2 about the y-axis. Alrighty, again, draw a graph. I know that this is going to be a parabola that gets shifted over 2. It's going to look something like that. And then we've got the line y equals 2. And I believe that actually touches at 2. So it's going to look just like that. So there's my region in question. I'm going about the y-axis. So since I'm going about the y-axis, this is definitely a shell problem. So we're going to put volume equals 2 pi. It's going to go from an x value to an x value. So to figure out where they intersect, we're going to set 1/2 x minus 2 squared equals 2. Remember, if it's on a non-calculator section, I would expect you to find the points of intersection, like I am. First thing that I'm going to do is multiply both sides by 2 to get rid of that 1/2. So now I'm going to have x minus 2 squared equals 4. The next thing I'm going to do is to get rid of the square. We'll take the square root of both sides. So I'll get x minus 2 equals plus or minus 2. And then I'm basically here have two different problems. I have x minus 2 equals 2 and x minus 2 equals negative 2. So to solve this one, I'll get x equals 4. And when I solve this one, I will get 0. So they intersect at 0 and then again at 4. My p of x, since it's just about the y-axis, is just going to be x. And my h of x is always top minus bottom. The top is the straight line, so the top is 2. And then minus the bottom is the curve 1/2 x minus 2 squared. And then we're good to go from here. Now it's just going to take a little bit of simplifying to get us ready to take the integral. Leave that x alone. 2 minus, when I'm going to have minus 1/2 x minus 2 squared. It really means x minus 2 times x minus 2. So if I FOIL that, I'll get x squared minus 4x plus 4. And then just distributing here, I'll get 2 minus 1/2 x squared. Negative 1/2 times negative 4 will be plus 2x. Negative 1/2 times 4 is going to be negative 2. I notice that my 2's cancel out. So if I distribute this x to both parts, just make sure I get all my parts here. If I distribute that x to everything, I'll get negative 1/2 x cubed plus 2x squared. Alrighty, now I am ready to take the integral. So if I take the integral, my 2 pi is just going to hang out there a minute. When I'll get 1/4 x to the 4th, so negative 1/2 times 1/4 will be negative 1/8 x to the 4th plus 2/3 x cubed. I get to evaluate it at 0 and 4. When I plug 4 in here, 4 to the 4th, and then divide it by 8, I will actually end up getting negative 32. And then plus, if I plug 4 in there, that would be 64. 64 times 2 is 1/28. And then minus, if I plug in 0, I will get 0. Don't forget that you have that 2 pi hanging out there. I'm going to get a common denominator next. This will be negative 96/3. So negative 96/3 plus 1/28 will give me 32/3. But then I do need to multiply by 2 pi, which gives me 64/3 pi. All right, problem 10, last one. The base of a solid S is the region bounded enclosed by the graph of y equals square root of x, x equals 5, and the x-axis. If the cross-sections of S perpendicular to the x-axis are squares, then find the volume of S. All right, again, we've got y equals the square root of x, and we've got x equals 5. Oh my goodness, my picture's really crooked. I apologize. You just have to turn your head sideways a little bit here. I'm going, all right, the cross sections are perpendicular to the x-axis, so they're going to go this way. Okay, so we need everything in terms of x, which we're kind of used to. I do have squares going on here, so I'm going to get volume equals. It's going to go from 0 to 5. And then I just need the area of x, and I'm going to do a little side trip. My area, since it's a square, will be side squared. And since I'm dealing with x's, it's going to be the top minus the bottom squared. The top is going to be the square root of x, and then the bottom is 0, and we get to square it. So I'll get the square root of x squared, and the square root of x when I square it is just x. So actually that formula for area is just x, which will make it nice and simple for us. Okay, from here, we are going to go ahead and take the integral of x, and we'll get 1/2 x squared. We'll evaluate it at 0 and 5. Alrighty, if I put 5 in there, 5 squared is 25, so this will be 25 halves minus 0, which will just give me 25 halves.